Hello and welcome to Pre-Algebra Lesson 37. In this video, we're going to learn about operations with mixed numbers. So the lesson objective for today is to learn how to add, subtract, multiply, and divide mixed numbers. So when we add or subtract mixed numbers, we're going to add or subtract the fractions first, followed by the whole numbers. So let's just start out with an example. We have 3 1/2 plus 6 1/4. So I want you to remember that if we see something like 3 1/2, this is really 3 plus 1/2, right? It's just written this way for convenience, right? We don't want to take up all the space with a plus sign each time. So 6 1/4 is really 6 plus 1/4. So to add these two mixed numbers, all we're going to do is just kind of rewrite them as 3 plus 1/2 and then plus 6 plus 1/4. And then I'm going to do some reordering. Remember, I can do that with addition because it's commutative. So I'm going to put my fractions next to each other. I'm going to put 1/2 plus 1/4. And then I'm going to put my whole numbers next to each other. So I'm going to put plus 3 plus 6. So now what I'm going to do, again, as I said, I'm going to add the fractions first, and then I'll add the whole numbers last. So what if I had 1/2 plus 1/4? What would I do? Well, I'd find my LCD, and between 2 and 4, I know the LCD would be 4, right? 4 is 2 factors of 2. 2 does not factor. So if I have 1/2, again, plus 1/4, I'd multiply 1/2 by 2 over 2 so that I could get the denominator of 4. So 1 times 2 is 2, over 2 times 2, that's 4. And then we're adding to that 1/4. So we'd add these numerators. 2 plus 1 is 3. And we place that over the common denominator of 4. All right, so let me erase all this and just kind of go back up to the top now. So we know at this point that adding the fractions here gives us the result of 3/4. So I'm going to put 3/4 plus, and then again you have 3 plus 6 there. Now adding the whole numbers are easy, right? 3 plus 6 is 9. You can do that in your head. So now when I look at it, I have 3/4 plus 9. If I just reorder this one more time to 9 plus 3/4, I can then use my convenient notation that I have up here, the way that we just write a mixed number, right? So this is going to be equal to 9 and 3/4. All right, let's take a look at another one. We have 6 3/8 plus 2 1/12. So again, what I'm going to do is I'm going to rewrite this. I'm going to put 6 plus 3/8. And then plus 2 plus 1/12. So I'm going to reorder this addition to where the fractions are next to each other and the whole numbers are next to each other. So I'm going to put 3/8 plus 1/12, and then plus 6, and then plus 2. And again, you don't have to do that. You can just kind of add these together and add these together, and you'd end up with the same result. I just do this so that it's convenient to see what we're doing. All right, so moving on now. We're going to add our fractions first. And let's just do this down here to make it convenient. So if I have 3/8 and I have 1/12, what's going to be my LCD? Well, it's going to be the LCM, the least common multiple, of 8 and 12. So again, how do we figure something like that out? Well, we've been working with fractions for a long time now. We know that 8 factors into 3 factors of 2. So 2 times 2 times 2. We know that 12 is 2 factors of 2, and I've already accounted for that, and then 1 factor of 3, so that's got to go in. So basically my LCD is going to be 2 times 2 times 2, or 8 times 3, which is 24. So when I'm adding these fractions, what I'm going to do is I'm going to first transform the fractions into equivalent fractions where they have a denominator of 24. So I'm going to multiply this by 3 over 3, and I'm going to multiply this by 2 over 2. So what we're going to get is 3 times 3, that's 9, over 24, plus 1 times 2 is 2, again, over 12 times 2, which is 24. So now we have our common denominator. We can just add the numerators. 9 plus 2 is 11, and that's going to be over the common denominator of 24. So let's erase all this and go back up. We know what the fraction part's going to be. It's going to be 11 over 24. So I'm going to put equals 11 over 24, and then plus. Now the whole number parts, 6 and then 2, we add those together, that's going to give us 8. And again, I can just reorder this one more time. 8 plus 11 over 24. And again, to write this as a mixed number, we just simply drop out that addition sign, right? Just for convenience. So this is really going to be 8 and 11/24. All right, let's take a look at one final addition problem, and then we'll move on to subtraction, multiplication, and division. So we're adding 9 and 1/5 plus 13 and 1/4 plus 2 and 7/8. Again, I'm going to just write this out as 9 plus 1/5 plus 13 plus 1/4 plus 2 plus 7/8. And I'm going to reorder it again to where my whole numbers are next to each other and my fractions are next to each other. Let me just put my whole numbers first. So let's do 9 plus 13 plus 2. And then plus, down here I'm going to put my fractions of 1/5 plus 1/4 plus 7/8. So let's take care of the fraction parts first. And we're going to scroll down and do that. So if I have 1/5 plus 1/4 plus 7/8, again, I need to find the LCD to start. So what's my LCD going to be? Again, it's going to be the least common multiple for these denominators. So of 5, 4, and 8. So 5 doesn't factor, so that goes in. 4 is 2 times 2. And 8 is 3 factors of 2. So because I already have 2 factors of 2 in here, I just need to add one more in. So the LCD is going to be 5 times 2, which is 10, times 2 again, which is 20, times 2 one more time, which is 40. So I need to rewrite each fraction as an equivalent fraction with 40 as its denominator. So for 1/5, I'm going to multiply by 8 over 8. For 1/4, I'm going to multiply by 10 over 10. And for 7/8, I'm going to multiply by 5 over 5. Okay, so 1 times 8 is 8. Over 5 times 8, that's 40. Then plus 1 times 10 is 10. Over 4 times 10, that's 40. Then plus 7 times 5 is 35. Over 8 times 5, that's 40. So we have 8 plus 10, that's 18, plus 35, which is going to give us 53. So we'd have 53 over the common denominator of 40. Now, when you get a result that is greater than 1, remember, you're working with mixed numbers here. So your fraction part has to be a proper fraction. This is an improper fraction. So what you want to actually do here is convert this into a whole number part and a fraction part, right? And that fraction part is going to be a proper fraction. And we remember how to do that, right? We take 53 and we would divide it by 40. So 40 goes into 53 once. 1 times 40 is 40. Subtracting, we get 13. We would have 1 and 13 over 40 as our mixed number there. So let me erase all of this. And we're going to go back up to the top. And I'm just going to rewrite this right here. 9 plus 13 plus 2 plus. I just found out that the result from adding the fractions was 1 and 13/40. So I'm going to put a 1 here to add along with my whole numbers. And then plus 13 over 40. This fraction part I don't need to do anything else with. So now I'm just going to add these whole numbers together. 9 plus 13 is 22. 22 plus 2 is 24. Then 24 plus 1 is 25. So I would have 25 plus 13 over 40. And again, as a mixed number, we just write this as 25 and 13/40. Okay, now let's look at some subtraction problems. And really, when you work with subtraction problems, they're not any more difficult, except for the simple fact that sometimes you'll be subtracting fractions, and the fraction you're subtracting from is too small. So you have to do a little bit of borrowing, and we're going to come across that in the next problem. So we're going to start out with 23 1/3 minus 20 1/7. So again, what I'm going to do is I'm going to subtract the fraction parts first, and then I'm going to subtract the whole numbers. So in other words, I'm going to take 1/3 and I'm going to subtract away 1/7. Now you have to do it in that order here because remember, subtraction is not commutative like addition. So I'm going to take 1/3 and I'm going to subtract away 1/7. Now to do this, I need to get a common denominator going, and my LCD here would be the product of the denominators, 3 times 7. And that's because 3 and 7 are both prime numbers. So I'm going to multiply this by 7 over 7. I'm going to multiply this by 3 over 3. And we're going to end up with 7 over 21 minus 3 over 21. And that's going to give me 4 over 21. Right? 7 minus 3 is 4 over the common denominator of 21. So now that we know the fraction part, we only need to subtract the whole number part. And again, I have to be specific about how I do it. It's 23 minus 20. If I do it in a different order, I'll get the wrong answer. So 23 minus 20 would be 3. So what we end up with is 3 for the whole number part, and then 4 over 21 for the fraction part. All right, let's take a look at another subtraction one. So we have 14 and 3/5 minus 5 and 13/15. So we would start this problem out the same way. So we do 3/5 minus 13/15, right? Just subtract your fractions first, get that out of the way. What's going to happen is you're going to find out that 3/5 is smaller than 13/15. So the result of this is going to be a negative number. Now we don't want that. So what we're going to do is we're going to end up borrowing from the whole number part. So let me show you how to do that. The first thing I'm going to do is pretend that I don't know that this number is smaller. So I'm going to start out by saying, okay, the LCD between the two fractions is 15. So I'd multiply this by 3 over 3. And what would happen is I'd see that, okay, I have 9 over 15 minus 13 over 15. And I'd say, okay, this is going to result in negative 4 over 15. What do I do now? Again, to correct this, I'm going to borrow. So instead of having 14 there, I'm going to rewrite this and say that this whole number is going to be 13. And instead of 3/5, what I'm going to do is I'm going to add 5/5. So that's where this 1 went. I took 1 away, and I basically said, okay, instead of having 14, I now have 13. That 1, where it went, I wrote it as 5/5, and then I'm adding that to 3/5. So essentially my fraction part now is going to temporarily be 8/5, right? So you can just think of this as having 13 and 8/5. And that's not how we write mixed numbers, right? We always want a whole number and a proper fraction, but we're just doing it so that we can perform our operation. So if I have this as 13 and 8/5, now when I look to subtract the fractions, what I'm going to have is I'm going to have 8/5 minus 13/15. Again, the LCD is still going to be 15, so I'd multiply this by 3 over 3. And what we'd end up with now is we'd have 3 times 8, that's 24, over 3 times 5, that's 15, minus 13 over 15. And you can see that 24 is bigger than 13, so you can do the subtraction and not get a negative number. So 24 minus 13 is going to give us 11. So this ends up being 11 over 15 for our fraction part. Now, when we subtract the whole numbers, now we have a different whole number to work with. Because we lent 1 to our fraction, we no longer have 14 as our whole number part, we have a 13. So we have to keep that in mind. So we would do 13 minus 5, and 13 minus 5 is going to give us 8. So 8 and 11/15 would be our answer. Okay, let's take a look at another one. We have 12 and 4/9 minus 8 and 7/8. So again, when I have a subtraction problem and I'm working with mixed numbers, I'm going to try to subtract my fraction part first, and then I'm going to worry about the whole numbers. So I would subtract 4/9 minus 7/8. 4/9 minus 7/8. Again, you got to do it in that order because subtraction is not commutative. Now, when I look here, I see that 9 and 8, they're not going to have any common factors, right? 9 is 3 times 3. 8 is 3 factors of 2. So really the LCD here is going to be the product of the two denominators, or 72. So I'd multiply this by 8 over 8, and I'd multiply this by 9 over 9. And when you do this, you see you have a problem, right? 8 times 4 is 32. So this would be 32 over 72. Minus 7 times 9, that's 63 over, again, 72. So when we perform this subtraction, we end up with a negative result. And although we can do it that way, it makes it more complicated. So to keep things nice and simple, let's erase all this. And I just want you to, again, temporarily think about this. We're going to borrow 1 from this whole number. So instead of 12, I'm going to have 11. And so this 4/9 here, I'm going to just temporarily add 1 to that 4/9, but just using fractions. So instead of 4/9, If I add 1 in fractional form, I'm going to add 9 ninths, and that's going to give me 13 ninths. So instead of having 4 ninths there, I basically have 13 ninths. And again, this is now 11 for the whole number part. So now if we subtract fractions, I would do 13 ninths minus 7 eighths. We're going to have the same LCD. So I'm going to multiply this by 8 over 8. I'm going to multiply this by 9 over 9. And let me just scroll down here so we have a little room. 13 times 8 is 104. And this would be over 9 times 8, that's 72. Then we'd subtract away 7 times 9, that's 63. Over 8 times 9, that's, again, 72. 104 minus 63 is 41. And this is over the common denominator of 72. So the result of subtracting the fractions would give us 41 over 72. So this is 41 over 72 for that part. And now we just subtract the whole numbers. So remember, I don't have 12 anymore because I borrowed to do my subtraction with the fractions. So I have an 11 here, and then I'm just subtracting away 8. 11 minus 8 would give me 3. So we'd end up with 3 and 41 over 72 as our answer. So now we're going to start doing some multiplication and division. And we're going to change something up here. Now when you add or subtract mixed numbers, generally what everybody's going to say is to add or subtract the fraction parts first, then add or subtract your whole number parts. Now, alternatively, if you wanted to, when you add or subtract mixed numbers, you could have converted those mixed numbers into improper fractions, perform the addition or subtraction, and then you can convert them back to mixed numbers if you have to. It's totally up to you which way you want to do it. It's just usually faster to do it the way that I showed you. Now, when we multiply or divide mixed numbers, we're going to convert each mixed number into an improper fraction. Once we're done, if it's required, we'll convert the answer back to a mixed number. Sometimes your teacher won't tell you to convert it back. You can just leave it as an improper fraction. Whatever they want you to do, just follow the instructions you're given. So we're going to start with 5 2/5 times 3 1/7. So what I'm going to do is convert each of these into an improper fraction. 5 times 5 is 25, plus 2 is 27. So I'd have 27 fifths times 7 times 3 is 21, plus 1 is 22, over 7. So again, when I multiply, I always look to cross cancel first. There's no common factors between anything here, so I just do the multiplication. 27 times 22 is going to give me 594. And this is over 5 times 7, which is 35. So our answer here is 594 over 35. Now, like I said, if you wanted to, you can leave this as an improper fraction. If your teacher makes you, convert it back to a mixed number. So let's do 1 or 2 where we convert it back, and then we'll just leave them as improper fractions moving forward. So 594, we're going to divide that by 35. 35 goes into 59 once. 1 times 35 is 35. Subtract here, 9 minus 5 is 4. 5 minus 3 is 2. Bring down the 4. 35 is going to go into 244 6 times. 6 times 35 is going to give us 210. Subtract here. 4 minus 0 is 4. 4 minus 1 is 3. So that's going to give us 34 as the remainder. So as a mixed number, this would be 16 and 34 over 35. Okay, for the next one, we have 8 elevenths times 4 1/2. So I'm going to keep 8 elevenths unchanged. That's already a fraction. And I'm going to multiply by 4 1/2 after I convert it into an improper fraction. 2 times 4 is 8, plus 1 is 9. So we'll have 9 halves here. We look to see what we can cross cancel. I know that 8 is divisible by 2. 8 divided by 2 is 4. So just think about canceling a factor of 2. That would give me 4. Cancel a factor of 2. That would give me 1. So now I basically have 4 times 9, that's 36. Over 11 times 1, that's 11. So I get 36 elevenths as my answer. Now again, for the last time, we're going to convert this into a mixed number. Again, this is something you should already know how to do. So if your teacher requires it, go ahead and do it. But again, a lot of teachers will just say, however you get the answer, as long as it's simplified, it really doesn't matter. So 36 divided by 11. 11 goes into 36 3 times. 3 times 11 is 33. Subtract and get 3. So if we write this as a mixed number, we'd have 3 and 3 elevenths. 3 and 3 elevenths. Now we have 4 2/5 times 6 1/4. So I'm going to convert each into an improper fraction. 5 times 4 is 20, plus 2 is 22. So we'd have 22 over 5 times, for this one, 4 times 6 is 24, plus 1 is 25, and that's over 4. And we can see we can do some cross-canceling here. I know that 25 is divisible by 5. 25 divided by 5 is 5. So this will cancel out completely and become 1. This will cancel and become 5. 22 is divisible by 2, and so is 4. So 22 divided by 2 is 11. 4 divided by 2 is 2. So now we have 11 times 5, that's 55. Over 1 times 2, that's 2. So we end up with 55 halves as our answer. Let's take a look at a few division problems now. So we have 8 and 2/9 divided by 7 and 1/2. Again, what I want to do is change each of these mixed numbers into an improper fraction, then do the division. So 8 and 2/9, I'm going to change this. 9 times 8 is 72. 72 plus 2 is 74. And this is going to be over 9. And we're dividing by 7 and 1/2. 2 times 7 is 14. 14 plus 1 is 15. So that's 15 halves. And again, if you're dividing fractions, the first fraction or the left fraction stays unchanged. So 74/9, we don't do anything to that. Then we're going to multiply by the reciprocal of 15 halves. So that's going to be 2/15. And we'll look to see if we can cross cancel anything. Nothing I can really do here. 74 is not divisible by 3 or 5, so I can't really cancel anything. So we just multiply. 74 times 2 is 148. And this will be over 9 times 15, which is 135. So my answer here is 148 over 135. All right, for the next one, we have -6 divided by 2 and 1/8. So we have -6, and since we're dealing with fractions here, I'm going to go ahead and write that as -6 over 1, and then divided by, I'm going to convert this into an improper fraction. 8 times 2 is 16, plus 1 is 17, so you'd have 17 over 8. Again, to divide fractions, this leftmost fraction, -6 over 1, will stay unchanged, and we'll multiply by the reciprocal of this fraction, so times 8 over 17. So nothing I can cross cancel here, so I just need to multiply. -6 times 8 is -48, and this is over 1 times 17 or 17, so we get -48/17 as our answer. All right, final problem. We have 2 and 1/5 divided by 4 and 1/3. So again, I'm going to convert each into an improper fraction. 5 times 2 is 10, plus 1 is 11. So this will be 11/5. And then divided by 4 and 1/3, I'm going to have 3 times 4, that's 12. 12 plus 1 is 13. And then over 3. So 11/5 times the reciprocal of 13/3 would be 3/13. Nothing to cross cancel. 11 times 3 is 33. 5 times 13 is 65. So we'd have 33 over 65 as our answer.